Hello, this lesson will be on conditional probability. We've already talked about the difference between independent and dependent events, so I need you to understand that conditional probability will be calculated when events are dependent. So remember that with dependent events, the second event's probability depends on what happened in the first event. So this is different what we have been doing, let's say yesterday, because the object is not being replaced. So remember, keywords to look for are things that indicate if the object is being replaced or not, to determine whether it's independent or dependent. So the first example. So let's say we are drawing marbles from a bag and we're keeping them instead of putting them back each time. So why is this dependent? Well, this is going to be dependent because replacement is not occurring. Okay? So let's see. If we have 14 marbles and 10 marbles, let's first find the probability of having a red and blue marble. Well, we need to, of course, know how many marbles we have total. So if we add 14 and 10, we get 24. So if we want to know the probability of red and blue, we first find the probability of the marble being red, which would be 14 out of 24, and we multiply that by the probability of getting a blue. But recall that replacement is not occurring. Since replacement is not occurring, we no longer have 23 marbles in the bag, or 24 marbles in the bag. There are only 23. However, there are still 10 blue marbles. So notice how that's going to be different. For our second probability, it's going to be reduced by 1 because one marble was taken out. When we multiply that together, we get 140 over 552. Okay? Next, to find the probability that we pull a red, then another red. We first remember that there are 14 to begin with, out of a total of 24. But then the second time, there are 23 marbles, yet the first one, since we drew it was red, there are now only 13 red marbles. So make sure you understand that. There is one less red marble and one less total marble in the bag. When we multiply our numerators, we get 182. When we multiply our denominator, we get 552. And there would be our probability. Next, we need to understand that for conditional probability, again, it only applies to dependent events. Let's see. Okay, sorry, I had to make sure I was on the right slide. So we've read this before. This is read as the probability of A intersection B. For conditional probability, because it is based on dependent events, we need to understand that we are now multiplying the probability of A times the probability of B given that A has occurred. If you see this vertical line here, what it represents is given. So this symbol is read as given. We read this whole statement as, the probability of A and B equals the probability of A times the probability of B, given that B has already occurred. So make sure you're able to read this out loud in words. So, of course, this means that A is already happened if we are finding the probability of B given A. In more cases than not, conditional probability occurs with dependent events. For example, in our classroom, what is the probability of randomly selecting 2 girls if I cannot choose a student twice? So we need to first think, how would I write that in symbols? What is the probability of randomly selecting 2 girls if I cannot choose a student twice? In symbols, we are going to denote the first girl and the second girl using subscripts. So this is the probability of girl 1 and girl 2, which would be equal to the probability of girl 1 times the probability of girl 2, given that a girl was picked first. Okay? So to find that probability, we first need to understand, of course, the total of girls and boys in the classroom. And then we would want to consider, then we want to consider if the girl 2 is chosen after girl 1, there are less girls in the classroom and less total students to choose from. So we will actually work this example in class. So be familiar with how to read it, please. Next, let's go ahead and look at example 3, conditional probabilities with tree diagrams. So we've already done tree diagrams before. It says to draw a tree diagram to model picking a 1, 2, 3, or 4 after selecting a boy or girl. So let's go ahead and start our tree diagram. And of course we can label it maybe boy, girl. And if there are 2 people and one's a boy and one's a girl, they each have a probability of a half of being picked. Then we are having a second event, so again a compound event, 1, 2, 3, or 4. So we'll label these 1, 2, 3, and 4. One, 2, 3, and 4. And of course each of these, because of this event, there are 4 possibilities. The probability of each would be 1/4. So this slide asks us to first determine, are these events dependent or independent? So these are independent events. Picking a 1, 2, 3, or 4 has nothing to do with whether you choose boy or girl. But when we find these probabilities, we want to be paying attention to what here it's asking. So let's take a look. To find the probability of picking a 4, we'd want to find find the pathways on the tree that end up us picking a 4. And if we go boy, then 4, that's one of them, and girl, then 4, that's a second. So I'm going to put a star here and a star here. There are 2 out of 8 possible outcomes. Okay, because we could have boy 1, boy 2, boy 3, boy 4, girl 1, girl 2, girl 3, girl 4. So out of 8 possible outcomes, there are 2 that end in 4. 2 ways we could choose 4. Boy 4 and then girl 4. Next, we are asked to find the probability of choosing a boy and 2. A boy and 2. So the probability of picking a boy is 1/2. And then the probability of then picking a 2 is 1/4. Oops. So if we multiply those probabilities, 1/2 times 1/4, from the 1/2 boy then 2, we get 1/8.